And we're live. All right, all right, all right. How's everyone doing? How's everybody doing? No, there are people here, I promise. People online, there are people here. Can I get some claps? Can I get a hi? Yeah, there we go. There, I told you. We don't have the cameras facing out. Anyway, welcome to Hacker Dojo. My name is Ed Chaudhry. I'm the executive director here at Hacker Dojo. Member since 2014. Now I help steer this ship. We have an awesome event tonight. It's the first of a series hosted and sponsored by Intel, the good people at Openvino. So give it up for Intel and the Openvino team. Shout out to Openvino. Very cool, very cool. So if you didn't get a chance, sorry for the folks online, but there's all these goodies and pizza and drinks. Please help yourself before we get started. So the speaker tonight is Chepe, Chepetronics. Have you checked out his repo? Some awesome repo. He has actually a new one he just came out with. It's actually what we'll be going through in the whole series. Today, we're going to kind of just go through the roadmap of what we'll be covering throughout the series. It'll basically go for this month and next month. We'll have 4 workshops, and then we'll continue into the next quarter as well with another 4 workshops. So it should be very, very good, very informative. We'll be exploring, we're going to go into some of the basics of Python. We're going to go through deep into, not deep learning, but deep into machine learning. And we're going to, get into some of the stuff and some of the cool applications leveraging Openvino. Before we get started, just wanted to give everyone a heads up that, Hacker Dojo is looking for more members. It helps sustain the dojo and helps bring these cool types of events. We actually have an opportunity to expand our space. So we do have a donation page. You could go to our homepage at hackerdojo.org. Just go to donate, and you can donate there, and you'll see all the cool stuff that we're doing and all the cool initiatives. Also, we have tons of events. I think last year we did over 1,100 events in 1 year, fighting through the pandemic, even opening a little late. So that's kind of good, right? That's pretty active, in-person events. And now we're also streaming as well. Well, that being said, and you got a chance to go check out Hacker Dojo, please do so when you get some chance. But without further ado, I'm going to give it up to Chepe. Come on, Chepe, give it up for Chepe. Right out of the bathroom, he's fresh. Hope you wash your hands. No, just kidding.
Hmm? They're still here? Cool. Okay. Hello. I am Jose Ruiz. A lot of people know me as Chepe. I will be speaking about deep learning and Python as a consequence to learn how to use a little bit of machine learning. It said not deep learning, just machine learning. It's actually the other way around. It's going to be around deep learning, not necessarily getting into the traditional machine learning realms. A little bit of announcements before we start. On the Github I'm sorry, on the meetup page, there was a repository linked that was not the correct one. So an apology for that. We're going to be using a new repository that I'm working on. That repository that was linked was for the previous session, which revolved around mostly Python, less about machine learning. And it was everything on a local setup. This time, I don't want to lose focus on the topics that I think are actually more interesting. So we're going to skip all the setting up your development environment and going to go straight into the topic of today, which that is deep learning. So today's just quick. So today's repository. I'm sorry, I can't find my mouse. Okay. So the repository is github.com/hackerdojo/python-ml. Okay. I'm going to be uploading all the contents for the following workshops here. And as you can see, there's already a little bit of content, mainly around the contents that we will be covering during this series. I don't know what happened to the video.
Could you please repeat the address in the browser?
I'm sorry?
Could you please repeat the address in the browser?
Yeah, so it's going to be... okay, sorry for that. I don't know where my mouse is. Okay, it's that. Can you see it? hackerdojo/python-ml. Okay, so let's get into it. This will be a series of workshops revolving around deep learning and Python. We are in session 1, which will be an introduction to Python, deep learning, and Openvino. Why Openvino? Openvino is a tool that will allow us to deploy machine learning models, deep learning models that we can train on our data or fine-tune or use pre-trained models and optimize them for running on different kinds of hardware devices, CPUs, GPUs, FPGAs, etc. So I find it very useful. I've used it in production, and it actually works. And it's a tool that as a developer will be very useful for you and will give you some better experience for your users when you're deploying a deep learning model as part of your applications. So who is this workshop for? This is a workshop that I designed for programmers that are not necessarily Python programmers, but that want to integrate deep learning into their new product development efforts. So what that means is we're going to revolve around what problems can be solved with machine learning and with deep learning. And we're going to be using Python as a tool. Okay? So what are we going to be doing? I'm going to speak a little bit about what these 8 sessions will be about. And then we're going to start the actual content for today. And then we're going to do a very quick machine learning example just so that you can have a grasp of what it will look like for for the rest of the sessions. So today is about the introduction to Python, deep learning, and Openvino. And the tools that we will be using as a development environment to test and explore, experiment with these new techniques. Next session will not be next week, but actually in 2 weeks. It's about everything about data preparation. A big part of using machine learning effectively revolves around understanding the data. Okay, I would say that it's where most of your effort will actually go once you understand the basic mechanics of training and deploying a model and using it for inference. Preparing the data is the most important step. So we're going to spend next session exploring some of the tools that will allow us to do that will allow us to visualize the distribution of our data, that will allow us to see if what we're doing or what we're programming is actually doing what we expect it to, right? So it's going to be around that. We're also going to explore the basic mechanics of training a model. If this is the first time that you're hearing the word training used in a programming context, it's just a fancy word to say teaching the machine what I want it to do, teaching my algorithm to do what I want it to do. And I do that by showing it the examples of the input and the examples of the output. And that process is called training. So we're going to explore that a little bit. We will not get too deep into the math of it because it can get pretty complex. And again, the approach for this series of workshops is for developers, not necessarily for researchers or data scientists. It's for developers who want to use machine learning or who want to leverage deep learning as part of their applications, as features that can be useful for them to provide better experience for their users. Okay. Next, we will be going deep into one of the applications of the tasks of machine learning, which is called classification. And then classification is just assigning a label or a class to an image. We're going to do image classification in particular. There's many kinds of classification. We're going to be doing image classification. All of the contents will be around image and computer vision. And this is one of my favorite examples for image classification because it can really confuse a model. So this is a collection of pictures. And what you ask the model is this a chihuahua or is this a muffin? Right? So one good thing that is simpler, but I've seen humans making mistakes with that one in particular. Next, we'll be going into detection. So that could be the next logical step after classification. What detection means is not only understanding what's in the image, but it's in what region of the image is the object that I'm interested in. So for example, this is a car, person, and sign detection in the example image there. So we will understand what's needed for that to happen. How can I show a computer a picture, and then the computer tell me, hey, this bounding box contains a bicycle, or a person, or a face, or a nose, or an eye, or whatever we're interested in, right? And then we will be using Openvino, and we will be comparing the performance before converting it to Openvino and after converting it to Openvino, so that we can see what the benefits are depending on where we are deploying our model. The next part is going to be around segmentation. We're moving forward in what we can actually do. Segmentation, we usually know segmentation as filters in social media, right? We call it filters. For example, in Snapchat or Instagram, where the model segments the face and does something to it, right? Segmentation is not only recognizing what an object is, but recognizing if a particular pixel belongs to that object, or belongs to the background, or belongs to a different object. So it's kind of a mixture between a classification model, because we are classifying each pixel, and an object detection model, because a pixel represents a location in the image, right? So that is what image segmentation is all about. And we're going to be doing semantic segmentation and instance segmentation. So those are like two different applications. One is a little bit more powerful than the other, and depending on what you might be doing, you would be interested in one or the other. Then on workshop number 6, we'll be talking a little bit about, model conversion and deployment with Openvino. So I think it's going to be very important to understand the difference between the stages of using machine learning as a developer. It is one thing to understand the problem. It is another thing to choose a solution and work around creating something that solves that particular problem for me. It is another completely different thing to use that trained model and use it in production. And in production can be on a server, so that I can use it through a web request or from an app, or it can also be deployed to a mobile device, for example, right? Or to a user's computer. We can embed it into another piece of code, and that will be part of what I want to explore, specifically with Openvino, and focusing on what we could be doing if we're maybe into IoT. Maybe we want to build a robot that has some object detection capabilities, and it's running on a Raspberry Pi. What do we need to do to optimize for that? Or maybe we have an Intel GPU, and we want to leverage that. So we're going to be exploring the use of Openvino for that particular scenario. After that, we're going to go back to the topics and the different tasks, and we're going to talk a little bit about generative models. Now there are a lot of interesting things happening here. In the example here, this is the output of DALL-E for creating images. And we're going to explore the basic mechanics of how that works, but most importantly, a set of tools that you can use to leverage generative models for your own benefit as a developer. And finally, we're going to be doing some advanced topics on model optimization. Now, this particular workshop is open for you to suggest what you want to work on, or if after this, please reach out to me and tell me, hey, why don't you do a project, for example, or let's work on something more practical. We can do that as well. So this particular one is a suggestion from me to you, but it's open for modification. So before we start, does anyone have any questions? Okay, cool. So let's move on. So what is machine learning? Well, machine learning is a part of artificial intelligence that involves the recognition of patterns, and being able to make predictions of data, right? The key idea behind machine learning is to actually show the computer some data, and so the computer, the machine, will do what I expect it to do. It's not magic, so we're going to be exploring how that actually works mechanically. But what we effectively do is we show some examples, and we show the output, and it figures out what needs to be done. So I show it muffins, and I show it chihuahuas, and then I show it a new picture, and it says it's a muffin. Okay? It is a very broad field that includes supervised learning, unsupervised learning, reinforcement learning. We're going to be focusing on the first one, which is supervised learning, which means I as the model creator, know the inputs and the outputs of what I want to do. On unsupervised learning, I not necessarily know what target I am working for. For example, if I want to group things together and do clusters of the things that are near to each other, I might not necessarily know how that's going to look, or don't have an example of how the output's going to look. And reinforcement learning is about providing some feedback to the machine so that the machine figures out what it really needs to do without necessarily, again, showing what the actual output you want, but more about around rewarding when the machine does something correctly, or punishing when the machine does something incorrectly. So that's another approach. We're not going to get into that, but I'm mentioning it just so you know that it's there. And then, again, some applications is around image, speech, recognition, natural language processing, predictive modeling. We're going to be focusing on computer vision, on image recognition, classification, segmentation, the topics that I mentioned earlier. Specifically, we're going to be working around deep learning. And now deep learning is a subset of machine learning that involves the use of neural networks that have many layers. That's a very high-level way of describing what deep learning is. But there's a series of techniques that allows us to do that. Why do we want many layers? Because many layers mean being that the machine is able to extract some features that are more complex than just geometric features, for example, right? The neural networks is a series of algorithms that were designed initially to mimic how the brain works, right? How an individual neuron works. In the context of machine learning, a neuron is called a perceptron, or that's how it was called when it was initially conceived. So we're going to look a little bit around that on the next session when we talk about training. We're going to see how it actually works, how it actually mechanically learns to do what we expect it to do. Now, the point of using deep learning is that we can train a model that's very general. And in the context of machine learning, what generalization means is that it's gonna perform better with data that it has never seen, right? So we're gonna be working around that, and a requirement for that is that we're gonna be using or deep learning models need a lot of data. Okay, so again, if we try to contrast deep learning or machine learning versus traditional programming, the key here is that we don't necessarily know the rules or the steps that the machine needs to take in order to tell us this is a muffin or this is a chihuahua. You know, we just show it a muffin, a chihuahua, and the machine figures out how that works. In machine learning, the program learns from the data. In traditional programming, we literally input the rules. So it is suitable for tasks where the rules are very difficult to define specifically. It is, in practical applications, when a problem has high complexity or variability, and in a personal experience, where I've seen machine learning being most useful is automating boring stuff that programmers are too lazy to automate. So there's people doing it. So very low-level, tedious tasks, that's where we're going to be seeing a lot of benefits from integrating machine learning into our product development. I can talk about two personal experiences where we saw an incredible change of user adoptions of products that I was involved. The first one was revolving image segmentation, basically to cut out a picture of a person that was going to be used on an official document in a government in Central America. Before adopting the technology, there was a team of people literally cutting pixels with a very old school tool just to segment, to cut out the background, because the pictures were taken in a location with non-ideal lighting. So those pictures would actually not pass the international requirements. So they needed to edit those images and cut out the person and do that. So what we did, yeah? Yeah, so what we did is we trained a model to actually learn what pixels were part of the person, to be able to separate that from the background and make those pictures compliant. That's actually currently used in production for a federal government in Central America. Another one is reconciliation tasks. So on my current project, what we're doing is we're reading paper documents, but we're doing it on a very large scale for enterprise applications. So what we do is we actually read paper invoices or receipts and reconciliate that with digital versions to find discrepancies between what was programmed to happen and what actually happened by the salesperson. So on that in particular, again, we're not replacing people's jobs, we're just making it faster. We're fighting a lag of around 6 months and bringing that down to 1 day, right? Because previously it was 6 months for the client to get their issue solved, and we are right now solving that in real time sometimes, or in a day when we're doing like large volume processing. Yeah?
Yeah, so just for my own understanding, because that's how I learned, we were just going over the image segmentation, although I want to understand the traditional programming versus machine learning. Traditional programming is that also called procedural programming?
Yep.
Where there's instructions that are written line by line.
Yeah, I'm going to repeat it anyway.
Yeah, so I could start from the top. I realize you're going over the subject of image segmentation, although the slide up is traditional programming versus
Yeah.
machine learning, and just from my understanding, because I'm still learning about what machine learning and AI is, so traditional programming is also known as procedural programming. For those that don't have that kind of background here, or are from different fields, procedural programming is writing instructions line by line, and the programmer writing instructions on the computer. The computer executes through each of those instructions. Whereas object-oriented programming is being able to go through classes or classification and giving it an abstraction, giving abstraction for different types of data types. Machine learning, so that second bullet point says that it's going through, it makes predictions out of patterns that you go through.
Yeah, so summarizing the question is, there are several programming paradigms that we're used to: procedural, object-oriented, functional programming. But all of those involve telling the computer what to do, right? So imagine you have the Chihuahua and muffin problem, right? Let me go back to that example, just so that we can think about that one. Imagine that this is a real-world problem. You need to know if the picture you are receiving is of a Chihuahua or a muffin. As a programmer, how do you solve that, right? So if we try to think what an image is, it's a matrix of numbers, right? Each position in the matrix represents, each number in the matrix represents a pixel and its colors, right, in three dimensions: red, green, and blue. And so from a computer's perspective, it's just a bunch of numbers. As a programmer, what would you need to do to tell the machine step by step how to differentiate a Chihuahua from a muffin? Maybe if you have one image, you can say, hey, look, if you are like around this part of the image and they are like darker than this other part of the image, maybe you can write something effective for that particular image. Show your program a new image, and then your code does not work anymore, right? So what would the next step of that could be? It could be like applying classic computer vision, right? So let's run an algorithm that detects the edges, right? That finds the highest points of correlation with some filters, with some geometric shapes, with vertical lines, with horizontal lines, with diagonal lines, whatever, right? And you would be fine-tuning some numbers there to kind of find those. Now, if I start showing you pictures with different kinds of lighting, taken with cameras that look completely different, with different levels of contrast, with shadows that cover part of the image, again, our model our program will not work, because we will be, that kind of model works, but is not able to generalize as well as a deep learning program. Now, if I can find a deep learning model where I say, hey, I have 10,000 pictures of Chihuahuas, 10,000 pictures of muffins. These are Chihuahuas, these are muffins. Learn it. And then I show it a new image of a Chihuahua and a muffin. If my model works, I don't necessarily need to understand the details of what's happening every time I show it an image. But I know that within certain parameters, it will generalize way better than what I initially tried with classic computer vision, or even with programming the rules. That's what I mean with programming the rules when I was in this slide here. We were there. Machine learning is suitable for tasks where the rules are difficult to define. How do you describe the rules of this is a chihuahua and this is a muffin, right? And I'm sorry I keep going back to that one, but it's one that I find particularly intriguing. Yep. Yeah, just say it loudly. Yeah, so the image segmentation example was a personal experience where I saw a problem where the rules are very difficult to define because each picture is different. So a machine learning model works really well there.
Would that work for different data types, such as audio data?
So there are different models for different kinds of data. It's not a one size fits all. You know, it's not like, hey, I have a classification model and then I can classify the universe. No, you know, you need to have data with a particular distribution that you will show, and then the new examples will need to have a similar distribution of the data that you initially used for training. If you start deviating from that distribution, then the machine learning model will not perform as well as you would expect it to. So answering your questions, are there models for audio? Yes, right? Are there models for video? Yes. We're going to focus on static images. We might mention how it works in other realms, but the focus of it is going to be image, and for no other reason than it is where there's more resources available. So I find it the easiest as an initial approach. Okay. Did I answer your question?
Yeah, that was a general question.
Okay.
Referring to image data, audio data, video data.
Yeah.
So any more questions, just feel free to come up to the mic so everyone online can hear the question too. And it also is a good cue for the speaker.
Yeah. Okay, so again, the process of machine learning involves pre-processing the data, selecting a model. Not all models do everything, right? Each model does a particular thing. Training that and evaluating, deciding if the model, after I tried to train it, is actually doing what I expect it to do. And then remember that deep learning requires a lot of data. It's heavy on the computation side. So we use a lot of accelerators. For example, with GPUs, we use TPUs, FPGAs. Depends on where you are deploying your model. If your cell phone CPU is enough to run inference on your model, or maybe you might need to be accessing your mobile's GPU, which these days are pretty beefy. They can do a lot. So, yeah.
I'm trying to think holistically.
Can you please use the microphone?
Yeah. No. Just turn it on.
Yeah, push the button. Just leave it on.
Yeah, so I'd like to think holistically for those that are in a different type of field. So
Oh, sorry.
I had a mentor
that is also from the electronics background, although he moved on to vacuum tubes and he had his own workshop at home, and eventually he moved on to power electronics and then picked up agricultural. So I'm thinking about the future of agriculture. I mean, thinking about if the population size, moves exponentially, how do we feed all these people, with crops and all this? Is there a way, like, say for instance, I have a tractor, and this tractor has a machine learning module algorithm on it. Is there a way to to recognize how much nitrogen is in the soil for each individual type of, or is there a way to
so-
program that?
I'm gonna say I don't know, because I don't know what you need to know that specific thing. So an important part of all of this is that machine learning is a tool. So can you use programming in agriculture? Yes. How? I don't know anything about agriculture, so I couldn't be able to tell you. I could be able to tell you how to program, and yes, so that you can use your general knowledge to solve your problem with a tool that's programming. Same thing with machine learning, yes.
It was such an interesting topic ahead. Can we move ahead with these topics? And,
Yes.
It's very interesting. Thank you.
Okay, yes, no problem. So the challenges about deep learning are, again, you need a lot of data, and we don't always have the data. So that's an important thing that you need to think about. I want to use machine learning to profile people, but I don't have a data set of people and their profiles. I don't know. That's, I would say, the greatest challenge. Model overfitting or underfitting. That's just technical terms to my program is not powerful enough, or my program learned the wrong concepts. It didn't learn to generalize, it just learned the data that I showed. Okay? There are challenges in the technical aspects of optimizing a model and tuning the actual training process, tuning the actual architecture of the model so that we can get the best results. And obviously, there are some ethical and social considerations for deep learning applications, right? So there are some things that we need to be very conscious about what kind of use we're going to be giving the technology, so that we stay within what a human would normally maybe do. We have a lot of examples around, for example, face recognition a few years ago, right? A lot of the early face recognition models were trained on Caucasian people. So whenever you showed black skins, Asian profiles, it basically confuses. I think you are someone else. So there can be the police arresting people who have nothing to do with the people that the system is thinking that it's doing. So that's like just scratching the surface of what the ethical aspects are regarding deep learning and machine learning. Something to think about, right? It's something that I think very valuable to have as part of our overall process. Now, let's talk a little bit about applications. We talked about computer vision, which is what we're going to be focusing on. But we're currently seeing a lot of NLP making waves in the news, right? In particular, a lot of ChatGPT in the past weeks or months. And then we also think, when we think AI, immediately we think about robots, right? So those things are going to be beyond what we're going to be working on. But it's interesting to know the context of everything that we will be finding when we start dipping our toes into the deep learning or machine learning realm. So let's talk about the thing. I'm going to skip a little bit around this because I already mentioned. Image classification is just knowing what the image is about. This is a muffin, this is a dog. Object detection is, here's the muffin, here is the dog. Semantic segmentation is this pixel belongs to a muffin, or this pixel belongs to a dog. Generative models are creating things that are not necessarily, that didn't exist before, right? Like giving a prompt to ChatGPT and getting an answer. Giving a prompt to DALL-E and getting an image. There's one particular site that I find very interesting, which is this person does not exist. So I don't know if it's live still. Yeah, this person does not exist. Let's see if it opens. It's not opening.
It was live a couple of weeks ago.
Yeah, maybe it will open later. But it's basically a site where you go and you see a picture. But if you analyze the picture, it's not a real person. It looks like a real person, but it is not. So I find that very, very interesting. So that's the intro around deep learning, machine learning. So I'm open to suggestions. Again, this is just a guideline about what I think we should be talking about on the next few weeks. But yeah, please reach out and let me know if you want to work.
Would you be able to do a simple hello world program in machine learning?
So it is possible to have models that create pieces of code. It's not, we won't be focusing on that, but if you go to ChatGPT and tell ChatGPT, write me a Python program for Hello World, it will do that for you. It might not necessarily be correct. So, but can you write programs with machine learning? Yeah. Questions about, before we dive into why Python? No? Cool. Question for you. Who knows Python? Okay. Who wants to learn Python? Okay. Who knows a different language? Okay, cool. That gives me an idea of how deep we might need to go for this. So, why Python? Mainly because it's easy to use. There are a couple of reasons, a couple of technical reasons why Python was initially adopted for machine learning. And one of them is that it is very easy to learn. And for people who are not programmers, because data scientists are scientists, not necessarily programmers, the technical aspects that Python solves makes it very friendly for a person that might not be as, I'm going to say, strict in their coding style and in their development processes. And so as a scientist, you want to run experiments fast, and you don't want to be worried about, now my data doesn't fit in my variable, so I need to go back and change the type and then see what breaks and what not. In Python, for example, an integer number can grow until you have memory available. You don't need to be aware of what's happening in memory, right? So that's very useful. Python also has a very large community of developers. And that means there's a lot of tools and a lot of libraries that will make it very easy for you as a developer starting to work with Python to actually leverage on other people's efforts. The open source community is amazing, and particularly in Python, it works in the environment, right? So there can be dependency hells, like in JavaScript and stuff, but it's, I would say, once you learn how to work with Python, it's less painful. Now, In particular for data science, there are a few libraries that make Python very, very useful. And depending on what you like, you might adopt one or two of these to work with. One's TensorFlow. TensorFlow is Google's version. It's Google's framework to build, train, deploy, and run inference on machine learning, right? PyTorch, it's kind of the same by Facebook, I think. Yeah. Keras is a higher level interface of TensorFlow that is now the official API. So Keras is a more Pythonic way of using TensorFlow, which is what we will be using a lot, just because it's easy to read. Then on the data science part, there's Pandas. Pandas is a library that allows us to manipulate data very effectively and do things to data sets very effectively. And NumPy is numeric library in Python. It's basically, if I want to do math in Python, I'm going to be using NumPy. And, well, machine learning is math, so. OpenCV is another library, very powerful for computer vision. It's also maintained by Intel. It's open source. It's been around for years. I remember learning it when I was in college, more than 20 years ago. So, and it's still maintained. So it's awesome. So the syntax is something that draws a lot of people into the Python ecosystem because Python reads like English, or tries to, right? So it's very easy to understand what's happening. There are some quirks, but you learn to work with that. And yeah, it's very flexible. It's deployable everywhere. So that's why we will be using it. I already went around this. NumPy and Pandas. Cool. We're also going to be using Jupyter notebooks. Now, as programmers, we are used to testing code in our machines. And we have almost always two separate environments, where we write code and where we run code, right? So we might be creating a website and we might be writing some HTML or JavaScript, and we use a code editor for that. And then we save the files, open a browser, load the page, and see what it looks like. And it might be doing what we expect it to do, or it might not. But there are two separate experiences. If we are playing to be a data scientist, and what we want to do is try things fast, then we want those two things combined in a single environment. Just like it would be on a notebook. Taking notes, you do things, you scratch, you try things, then you change your mind, you go back, you erase things, and try again. And that's what our Jupyter notebook allows you to do, but in Python. It allows for very easy experimentation, prototyping, and collaboration. We can execute code, we can document the code itself, we can run a routine, write a routine that does things, and then we can write the documentation, or we can write the requirements of what we want to do. What I like to do, for example, is I like to outline the different series of steps of what we will be doing, and then I fill the spaces in between with code. And that's a very easy way of knowing what I'm going to be doing, and then focusing on one thing at a time. And effectively, in the end, I have documented code, right? Because I know what I'm going to be doing, and then I write a snippet of code that does that very simple thing, and that's enough. They're commonly used for data analysis and mostly data science, machine learning, and all the popular libraries provide a set of notebooks as tutorials, examples, or learning resources. So it's also very useful to know the tool just because of that. We might learn about TensorFlow today, but if tomorrow we're going to try PyTorch, it's very likely that the most useful resource that we will find is a Jupyter notebook somewhere with the things that I want to explore. Right? Yes?
Yeah, I also wanted to quickly,
Thank you.
I also wanted to quickly plug a Jupyter Lab for anyone getting in the Jupyter Notebook. So it's kind of like an extended Jupyter Notebook that lets you manage multiple files and shows variables and all that stuff. So it's a great tool for anyone getting into it for the first time.
Yeah, it's basically an IDE, right? While Jupyter Notebook could be like working on a file, Jupyter Lab is basically an IDE where you can have project levels of things. And you can combine Python scripts with notebooks, with a bunch of stuff. So super cool tool. That's what we're going to be using for all the examples around this. Now, if you're new to Python, my favorite resource is the official documentation. And that sounds very boring, very, very boring, but it's true. It is true, and there are some reasons for it. It will show you the documentation for a particular Python version that you might be working with. It's important to know that not all Python versions are the same, and not all of the machine learning tools work on all of the Python versions. Actually, once you choose one, you should stick to that, because changing versions is painful in this world. I like shiny new things, but I still maintain some code that needs to be running on Python 3.6. Just because changing to Python 3.7 or more implies rewriting a lot of code. So still, if I want to go and fix a bug in that particular code base, I can go to the official documentation, select the version that I'm working with, and find the documentation that's relevant to that particular version. So for that reason, it's very, very useful. Codecademy is where I personally learned Python initially. I am an electrical software engineer. I am an electrical engineer who became a software engineer as a professional. I learned to program in C for embedded systems and assembly. So Python was like not something that I worked with until like 10 years after I graduated. And I had been doing a bunch of other languages. And I learned Python in a week and a half in Codecademy. And 2 weeks later, I had effectively deployed a project for a client using Django. So I still recommend it. There are free and paid courses. Very effective, very, very effective. There's this particular book, Learn Python the Hard Way, one of my favorite to recommend as well. There's an example of the book. There's an online version as well. So awesome book. And then Coursera has a lot of courses revolving Python and revolving machine learning. I remember taking a specialization about machine learning from the University of Washington several years ago. It was great. So these are some resources to have on hand. And obviously, please reach out to me if you want to learn about a specific thing, or if you want to do something, hey, how can I deploy a REST API? Or what's the best way to write a web app where I don't want to deal with JavaScript? I want to write everything in Python. So I might point you to the right spots for that. Cool. Finally, how are we? Yes.
.org or .com? .org or .com?
For Codecademy? I think it's .com. Let's see.
Because if it's open source, it might be.
Codecademy, it's .com. Yeah, so it's.
Yeah, that's what WordPress is different, short and full.
Yeah, but here you'll see whatever you want to learn. So Python, you here, and you're going to be learning Python 3. And then you can obviously
Yeah, so it's .com or
.com,
Thank you.
codecademy.com. Yeah. Again, that's how I learned. So I recommend it. It's effective. It's what I do for a living now. Now, what are we going to be using for our development environment? I'm going to be presenting two ways of achieving the same result, which will be running a Jupyter notebook. And this comes from, I mentioned before, at the end of last year, we ran a series of workshops where I was interested in people learning how to set up their machines. And what I found is that even if some people understood their environments better, I invested a lot of time that could be used for content in the workshops, just helping people get around particular issues that were happening only to them. Still, if you're interested in running Python and the environment natively, I'm happy to help. And I'm here at the dojo, and I can help you whenever you want set up your machine. But for the time being, and as the official tool for this, we're going to be using Docker images. Docker basically solves the problem of it works in my machine, right? It's a way where developers can write code, run it effectively on their machine, and then move it to a server or whatever, and run it there. And it does the same thing because it's the same environment, although it's not a virtual machine, but it kind of is. Containers are very lightweight, very portable. If you don't want to be pulling an image, you can build the image yourself on your computer and store it there. And it's very flexible what you can do with Docker. I will be providing, not for this particular workshop, but for the other 7, I will be providing specific images so that will contain the code and the tools needed so that you just run one command and start running it. Okay? You can even run it on a server if you have access to an AWS or Azure instance or whatever, right? So you can run it there and forget about it, log into it remotely every time you need. And again, this will hopefully eliminate any potential setup issues that our group might have. I'm still open to help you if you want to go the hard way, and I repeat that because that's what I like to do. I like to have everything installed natively because I like to understand what's happening and what issues are around there. So for that, if you don't have Docker installed, it's very easy to set it up. Go to docker.com. You're going to see, so if you go to docker.com, you're going to see download Docker desktop. Depending on your operating system, download that, follow the instructions, and set it up. You're going to follow the wizard, and after the installation, it's going to give you, it's going to prompt you with a command to test if it's actually working. Basically, you're going to run Docker run hello world, and that will go to a server, pull a pre-baked image, run an instance in your machine and show you hello world. And now you know it's working. Okay? The other way is going to be a remote setup. This is useful if you don't want to use any space in your hard drive, or if, like me, you have an Apple Silicon Mac and an Intel machine somewhere else, and you want to be working with both. Maybe it's better to work in a centralized manner. So I recommend two particular sites for that, platforms. One is Google Colab, and the other one's Kaggle. So Google Colab is a free service that provides limited resources for running Python notebooks, and it has a lot of the machine learning tools already pre-installed, and you can even modify what you want to support. And Kaggle is a data science community platform that also provides access to Jupyter. So the mission of Kaggle is actually not necessarily the particular platform, but they provide you with a platform, right? I love Kaggle. I learned a lot just reading what other people have done on Kaggle. If you don't know, it is a platform where there are a series of challenges where people can participate and create machine learning solutions, or solutions in general, to particular problems. And so all of those are published there, and most of them have public data sets that you can use for training, which you will find it is a challenge to have a high quality data set, right? One thing is to have a lot of data, another thing is to have a high quality data set. And then, again, both of those services allow you to run your Python code and visualize the result directly. So if you want to run the example locally and you already installed Docker, this is the only line that you need to run. Docker run -it -rm -p 8888 :8888 TensorFlow /TensorFlow :latest -Jupyter. What that will do is it will go to a server, download the pre-baked image that includes TensorFlow and Python with Jupyter Notebook pre-installed. It will run it on your machine, and it will show you a link. So, for example, Docker run. If I run that, I have already pre-pulled the image. So the image already exists in my machine. You might see what's happening. Okay. I don't know why it's not running the actual image. Give me just 1 second.
Does Docker PS work?
Yeah, it's Docker is stopped. Let me restart Docker. Okay, so for some reason, Docker is not working in my machine. Let me see what's happening. Docker. Okay, so this is Docker desktop on Mac. If you have Linux, you might not even need Docker desktop. You do everything on the command line. Okay, it's not up to date, but now I think I should be, yeah. So you run it, you're gonna see a bunch of stuff, but the important part is this one. You're publishing on your local host, port 8888, your service. If you click on that, you're going to see this, okay? And there, this is an image. This is the official image published by Google for TensorFlow. This is the latest version. You can choose a particular tag if you want to work with version 2.0 or 2.1 or 2.1.1 or whatever. So yeah. And we're going to be working on classification. Now, why did I mention online resources? Because you might find that you start running your code, and then when you get to the actual code, like this one, it crashes, right? Why does it crash? Because the actual image is built for an Intel CPU or AMD 64 architecture, and my computer is ARM compliant, not AMD 64 compliant. So even though the translation layer works for some things, it crashes for some other things. Okay, so what we're gonna actually do is we're gonna go, in my case, I'm gonna go to Google Colab. And then when you go to Google Colab, it shows you like, you create an account, you put in some data, and then you're gonna be running whatever you want. There are some examples provided off the shelf for you to try. I'm gonna be running the classification example by TensorFlow. So this is the actual same notebook that we were seeing here, okay? Only this is Google Colab. Is anyone lost at this point? Because I see a lot of faces like, looking around. No? Okay, cool. So, how do you use this? Well, it's basically an interactive environment where you can either run this little play button, no, not that one, this one, and it runs the cell. This is not actual code, but this is code. So when I run it, it actually runs the code and shows me the result on the bottom, okay? And then it has some documentation about my code. So this is the first example provided as part of the Docker image. Is the example about classification. And it uses a famous open source data set called FashionNist, which is 70,000 images, very small images, in 10 categories of fashion items, shoes, t-shirts, etc. Right? So what we're gonna do is we're gonna train a very simple model where you show an image in the same format, and it tells you that's a shoe, that's something else, you know? So we can run this code, and then we can explore the data set. Can you read this, or is this too small? Maybe that's better? Okay, I'm gonna close this. Okay, sorry for that. So, as you can see, don't worry if you don't understand the Python lines today. I'm gonna give you some homework if you want to understand. You need to know some Python to work with machine learning. You don't need to be an expert. So this is just loading the data set. Then we are splitting the data set into basically 4 variables. A tuple of training images and training labels, and a tuple of testing images and testing labels. And that's because the data set comes pre-split, like that, in a tuple of 2 tuples when we call this function, load data. And so we split that, and then we can see, what do we have? We have these 10 different classes: t-shirt, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, and ankle boot. And we're going to be using those 10 classes to know what the image that we're showing it belongs to. So what happens if I show a picture of a dog? I don't know. It will give me one of those 10 classes. Yeah, and that's related to the question you asked. Can I use a pre-trained image, a pre-trained model for whatever I want? Well, it depends on what you train it on, right? So we're going to be training it on these 10 classes. And then we can see that our data set, on our training set, looks like 60,000 images. There are 28 times 28 pixels. So our 60,000 images, 28 by 28, very small. And then we can see that each of them are actually a NumPy array. And our test set is just a portion of the data set that we're going to be using to validate that the training is going where we want it to. So on the next session, we were going to be talking about the mechanics of training a model. But basically what that is you split your data set and say, this set of data I'm going to reserve to validate what the model learns when I show it this other set of data. So you run a series of training cycles, and then you test it with a fixed set of images that doesn't change, right? So, and then you know if it's actually generalizing to a certain degree. We said on the Jupyter notebook, we can visualize things. That's why it makes it useful. How many lines of code would you need to write in any language to show an image, right? Even in Python, if you're running a Python program, if you want to show an image, you need to write a bunch of code just to display the image. So that's the advantage of running Python code inside an environment like Jupyter Notebook. You run the code, it shows you the result, and it knows how to display some data, like graphs, images, etc. So we're using here some different colors to display the image. And then we can also sample our data set and see what it looks like, right? So this is a sample of our data set. And now that we have already explored that particular example, we're going to actually build the model. And this, as I mentioned, is a very simple model. It's one layer of 128 neurons. So we have an input that's 28 by 28. Then we're going to have 128 neurons, and then we're going to have an output layer of 10 neurons because we have 10 different classes, right? So we have one neuron per class, okay? So we run that, and then the next step, which is a mechanical step, is we're going to compile the model. And for compiling the model, we are also going to set up some stuff that we will be, again, talking about in the next session. But we're basically going to be using, specifying an optimizer. Okay, so an optimizer is how will the training process know if the training is going well or not. Okay? I'm going to be using an optimizer called Adam. Again, today it might sound like gibberish. There are several optimizers. I'm going to use Adam. Then I want you to use a particular loss function, which is how are you going to measure the errors that happen every time you run an inference cycle. And you're going to track some metrics, like accuracy. Basically, we have two main metrics, or three, which are loss, which means what's the dimension of the error, according to the loss function that I'm providing. There's accuracy, which means how correct the model is. And for some models, we could also use precision. It depends on what you're training for. And then we're going to train the model. And for that, we're just going to run model.fit. And what that does is a very high-level function call to run a training cycle. What's happening during the training cycle is this thing is cycling through the data set. It's showing it over and over and over again. And it's measuring every time it goes through the data set. That's called an epoch. Okay? At the end of each epoch, it's showing me some metrics. So we can see that at the end of the first epoch, the loss was 3.3, and the accuracy was 0.69. Then the next one, it went all the way down to 0.64, and the accuracy went up, 0.68. It kept going down and down and down, and we're going to be running just 10 epochs. Again, this is a very simple model. It trains very fast, and fast enough that I can show it train, right? I was telling you about training models. My personal experience training some models for production use. That particular phase segmentation model that I trained, it took me around 10 days on my personal machine, which has a couple of NVIDIA GPUs. It's a funny story because my in-laws were visiting, and that machine is particularly noisy. So on that vacation, they didn't sleep very well. Okay, so this is now ending. And we can see how it went just on 10 epochs from 3.3 to 0.49, and from 0.69 accuracy to 0.83. Remember, accuracy means how correct the model is, right? So we can see how it actually performs by running this other magic function that evaluates. And what it does is it runs inference on the test set and gives me the metrics that I already saw in the previous cell. And then, once we have a model trained, now we use it, okay? And for that, we're going to be using a probability model called, that integrates a softmax layer in the end. And what that does is it gives me the output of the 10 neurons are actually the probabilities of the example belonging to any of those classes. So if the first neuron is the one with the higher activation, with the highest number, that means that the image most likely belongs to that particular class. So we can then get the index of the one with the highest probability, which in this case, as we can see, is this one here. And we can then verify some of the predictions, right? So, for example, this is we're displaying the image that we showed, which is that ankle boot, and the different activations here, right? So the model is very, very, very sure that this is actually an ankle boot and not a t-shirt, right? And we can see that on several images. If we change the index here, we're going to see like different things happening for different images, right? So this is a code. Okay, so that's a sneaker, and we can see like the probability distribution here. And so this way is how we will be interacting with the Jupyter notebook, with our Python code, using our deep learning framework, okay? We're going to be doing data manipulation, feature engineering, model designing, model training, model evaluation, and we're going to be doing a little bit of deployment and optimization for those models. Finally, we will be also exploring what you need to do to deploy that model into production. And that's what all of the previous code is what you need to do to train the model, which is a lot of lines of code. And then if you just want to use it, this is actually the only line of code that you need to use it for new images, right? So two very different tasks, running inference and training a model. And you are welcome to explore this particular notebook. It's published as part of the TensorFlow repository, which is like GitHub TensorFlow. And then there are a bunch of repos. They have a lot of examples. I invite you to explore those. It's where we're going to start next with a different classification model, but a classification example. But that's what I got. Please, I appreciate your feedback. If you think this is interesting, if you learned something today, if you didn't learn something today, please let me know what I can do to make it better for you. Thank you. Questions? No? Yes? Yeah. If you have a question, please come to the microphone and so that everybody knows what you're asking.
Quick question. Where can we find the classification Jupyter notebook? The one you're showing.
So I'm going to do two things. I'm going to put it in the workshop 1. I'm going to put it here in the repo, just so that you know that it's there and you can run it. And I'm going to also include in this repo a link to where that comes from.
Thank you.
Okay?
Is it Python, can you embed a piece of Python to HTML?
Can you repeat that, please?
Can you embed Python code, a piece of code to HTML?
You can use Python to build web applications. HTML is markup language to build, to tell a browser how you want to display things in a browser. Python is something that runs procedurally on the back end. So you can run Python to write HTML, produce HTML for you, but not the other way around. I think there are a couple of projects that allow you to use Python on the front end, But basically what happens is, in summary, HTML runs in your computer, Python usually runs on a server. Okay?
Thank you.
Quick question
Yes.
about hardware. Okay. So the new like M1 and M2 chips, they have this neural engine. Is that for actually running the convolution networks or for training? Because I know that training is mostly done with GPUs, right?
Yeah. As far as I know, you can train, but it's not as efficient as running on an. In my personal experience, I have always trained on NVIDIA GPUs. Nowadays, you can train on Intel GPUs. You can also train, if you go to Google Colab, you can train on TPUs. But I don't know if you can actually use the neural engine for training. As far as I understand, it's for inference only.
Gotcha. And is there a big difference between Radeon cards and like NVIDIA CUDA?
Between what?
NVIDIA
NVIDIA and what?
and Radeon?
Yeah. You can run TensorFlow on both, but CUDA is an NVIDIA only thing. And so if you go, for example, to the official TensorFlow things, they only support NVIDIA. And unfortunately, that's because they were there first. So most of the frameworks adopted NVIDIA. There are other efforts. I think for training specifically, NVIDIA tends to be like the less hassle. Let's put it that way. For inference, though, running inference on an NVIDIA GPU on the cloud is expensive, very expensive. So for that, you might want to look into optimizing your model, for example, with Openvino and running in a CPU with good enough performance. Or if your model is large enough, you might want to look into a TPU or other kind of accelerator in the cloud. Because running an NVIDIA GPU on the cloud can be quite expensive.
Is it a matter of how many cores they have, or is it intrinsic to like it being a floating point calculator?
Okay, I'm going to try to not get too deep into the details. You need a GPU for training because basically you can do a lot of very accurate calculations at the same time, right? A GPU is basically a bunch of small cores with specialized operations so that you can parallelize a lot of the things that are happening. For example, you can visualize that for an image, right? You process the whole image at once. Whereas if you were on a CPU, you need to process pixel by pixel. So training on a CPU is possible. It's just super slow.
Gotcha.
Right? And then once you have a pre-trained model, the process of inferencing involves just one pass of those operations. Remember that in training, you're feeding the data over and over and over again. Large data sets, millions of images, right? But then for inference, you just want one.
Right.
Next question.
Gotcha. Thank you.
Just to summarize, we went over, the question is, okay, so then you're going over the GitHub as well as the Jupyter notebook. So I have a GitHub account. It's not populated as much as I would like it to be. I had a previous account that I've been locked out of, so I'm going to repopulate it. So Jupyter Lab is for note-taking while you're writing the code,
So
programming.
Jupyter, there are two different tools.
Two different tools, okay.
GitHub?
But you can use them in conjunction.
Yeah.
Okay.
GitHub is, or Git, is a code versioning tool. It allows you to record your progress.
Version control.
For versioning.
Okay.
Version control. And then Jupyter Lab is for running code.
So can I find your example of the classification on
I will
GitHub?
put it on this repo.
And I can remote run it on Cargo or no matter.
Yes, you
workload.
upload the notebook and run it there.
I'll upload to it and I can run it by test by myself. Okay,
Yes,
thank you.
and you can write your own as well.
Okay, thank you.
Jose, Chepe, thank you so much. Again, give it up for Chepe.
Thank you.
Awesome. So our next session is March 7th. And so we gave some time. So you can ramp up, be sure to check out the repo, set up your environments, because we're going to start moving faster from here.
Yep.
We did a lot of overview, but now we're going to start digging in.
Yeah, actually doing.
So yeah, next session, March 7th, you have a lot of time, ramping up, getting sharper with your Python. I have your environments ready to go for the next session. And again, thank you so much to Intel Openvino team for helping sponsor this and making sure this comes together. And we're happy and excited that we'll see you in the next 7 sessions. It's gonna be good. I'm excited.
Yeah.
Thank you. Take care.
Thank you.
Have a good night.